Okay, again, the focus of our work in section 3.5 for geometry is going to be on parallel and perpendicular lines. We've got some theorems. We know that slopes of parallel lines are the same. There's a couple things here that just come up. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. The reason why we talk about non-vertical lines and not included here, when we look at any vertical line and we think about the slope of a vertical line. Slope of a vertical line means that we're finding rise over run. And in a vertical line, its rise can be anything. It's going to be just going up and down. But when we talk about the run of a vertical line, there is no run. There is no left-right behavior. And if we were to decide that we could put any number up top and say there's no run, we'd wind up dividing by 0 in our slope calculation, and division by 0 is impossible. And so what you'll find out is if you go into your calculator and divide anything by 0, I believe we've even actually done this. This is all about why do they leave off vertical lines? Because slopes actually have no slope or an undefined slope, because division by 0 is undefined. So that's the only thing there that note is about, is why do they talk about vertical lines different than others? But we do know that parallel lines have the same slope. When you talk about, and vertical lines are parallel as well, they just don't have a number we can put to their slope. When you go down into the next theorem, this talks about slopes of perpendicular lines. In the coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. The reason why that is true is because perpendicular lines, I'll show you the math behind it, perpendicular line slopes are opposite reciprocals of each other. Perpendicular lines have slopes that are considered to be opposite reciprocals of each other. Now, let's get to the math here. Perpendicular lines have slopes that are opposite reciprocals. Perpendicular lines have slopes that are opposite reciprocals. The opposite reciprocal of 3 would be -1/3. And if I want to talk about the math here that's going on, 3 times -1/3, the product of those two numbers together, you can check me in your calculator, is going to be -1. If I think about multiplying fractions, 3 times -1 is -3 up top. 1 times 3 is 3 in the bottom. -3 divided by +3 is -1. 2/3. How about -2/3? What's its opposite reciprocal? Flip it, change the sign. If I were to multiply these two together, -2/3, I'll leave the negative sign up top just to do the math, over +3/2 is going to give me -6 over +6. It's -1 again. So the idea is that opposite reciprocals always are going to have a product of -1. Perpendicular lines have slopes that are opposite reciprocals. When we multiply the slopes together, we're going to get -1. When you're ready to move on, turn your page. All right, now, theorems relating slopes. We're going to skip over problems 1 and 2, these extra practice. This is related to that directed line segment idea that we're not covering. Now, when I go into problem 3 here, problems like this, I see it on your homework practice, on your test, everything. Determine which of the lines are parallel and which of the lines are perpendicular. We're going to do some looking. We're also going to do some quick calculations. It seems to me that P and Q are probably parallel lines. It seems to me that P and Q are probably parallel lines. If that were the case, then we should be able to count or calculate slopes and find out that their slopes are the same. What I'm going to have you guys do is take a look at line P. And on line P, boy, this is going to get probably a little bit interesting with colors, but I'm going to grab yellow along line P. If you guys would please take a look at your line P, and I'd like you to, let's count rise over run from the point -2, 1 up to 1, 4. To get from -2, 1 to 1, 4, walk the path. What would be the rise? What would be the run? If we walk the path, rise is 1, 2, 3, run is 1, 2, 3. Line P slope then has 3 over 3, which is 1. So just picking out points there. I could also be calculating, might as well use this area up here. I could also be calculating slope by doing the math with the difference of the y's divided by the difference of the x's. But since we're in a picture, we might as well make our life easier and just count. Now the other line that I thought could be parallel, parallel would be line Q. If we go over and take a look at line Q, put your eyeballs on your line Q. And I see 2 points that are highlighted on line Q, 0, -4, up to 3 and -1. If I were to walk the path, rise, run. I'm on line Q. From this point to this point, I would count 1, 2, 3 as a rise, 1, 2, 3 as a run. Line Q, 3 over 3 as well. Wouldn't have mattered if it was 4 over 4. What I do know is that because these two lines have the same slope, P is parallel to Q. That's one conclusion that I can draw. Looking at those two slopes, P and Q are parallel. Now, my next move is to go in and grab line R, then line S, then line T. One thing about each of these that I want you guys to notice is that R, S, and T are all three are slanting downwards. And so when I get done with R, S, and T, I need to have negative slopes for each of those. Positive and negative slopes, positives go up from left to right, negative slopes go down from left to right. Focus in on R. Because these lines are slanting down, as soon as I start wanting to count rise over run, in every one of these, my rise is going to take me down. So on point R, line R, you can look and start up at -2 and 4. And let's count rise over run down to 2 over 1. Down 1, 2, 3, and I'm trying to take the path over to 2 over 1. I'm going to go down 3 and to the right 1, 2, 3, 4. The slope of R is going to be -3 over +4. Down 3 is represented by -3. The run of 4 is represented by my +4. Is there anything here that I need to back up to? Anything that you guys are missing? Or I'm going to move on to line S. Line S is the downward one that's in between the others. With line S, I'm seeing a path from the 2 points that I'm pointing at here. Once you kind of get your eyeballs on those 2 points, go to your paper. It's going to be a rise going down, 1, 2, 3, and a run to the right of 3. Down 3, right 3 to stay on line S. Down 3, right 3. That's actually going to give me a slope of -1. That's going to give me a slope of -1. R and S aren't parallel, nor do they look like it. Didn't look like it in the beginning either. My next move then is to find the slope of my last line, line T. Line T, where am I at here? Slope of line T. I've got 2 points that are highlighted on T. I'm going to go down 1, 2, 3. Oh, how do I get there? There we go. I'm going to have to go down 1, 2, 3, and then to the right. 1, 2, 3, 4. Let me count that again. Down 1, 2, 3, right 1, 2, 3, 4. Sure enough. Down 3, right 4, a slope of negative 3/4. Couple of things that I can observe right now. Because R and T have the same slope, I can say that R is parallel to T. I'm just going to put a loop around it. That's one more conclusion I can draw. Slopes are exactly the same. Now, as far as opposite reciprocals go, love this example in here because it's pointing out that 1 and negative 1. What happens when I multiply 1 by negative 1 together? 1 times negative 1. What do you get? Nobody knows. 1 times negative 1. What is it? Negative 1. 1 and negative 1 are opposite reciprocals of each other. Their product is negative 1. If 1 and negative 1 are opposite reciprocals of each other, then we can draw a couple other conclusions. Line P is perpendicular to line S. 1 and negative 1 are opposite slopes. And at the same time, if P is perpendicular to S with a slope of 1 and negative 1, Q is also going to be perpendicular to S with a slope of 1 and negative 1. So figuring out all the slopes gives me the opportunity to go and look and see how their numerical measures compare. If they're equal, they're parallel, like we had with P and Q and R and S. If their product is negative 1 or their opposite reciprocals, we have perpendicular lines. Now, moving to number 4, we're going to have to use our slope formula. Y2 minus Y, oops, I don't have a Y1 right there. Did you write it down up here? Because I'm going to slide my paper. We're going to have to calculate using the slope formula because tell whether the lines are parallel, perpendicular, or neither and justify your answer. Well, the only way you can justify your answer is by showing slope. I'm going to use line 1. I'm going to do its slope with a little m subscript 1. In the numerator, I'm going to have to take x1, y1, x2, y2s, and plug it in. Grab your y values and put their difference in the numerator. Yep. In the numerator should be y2 minus y1, and this is for line 1. So then I'm going to have 2 is the y2 minus 0. The x differences go in the bottom, x2, negative 2, minus x1, which is 2. 2 minus 0 is going to give me 2. 2 over negative 2 minus 2 is going to give me negative 4. I'm going to reduce that fraction down to negative 1/2. y2's difference up top, x2's difference in the bottom. Questions about that one before I go on to the second slope calculation? We've got to decide if they're parallel. If so, their slopes would be the same, or perpendicular. If so, their slopes would be opposite reciprocals, or neither. Their slopes don't show either of those relationships. So I've just got another set of x1, y1s, x2, y2s. I'm going into my next calculation. The difference in y's in this is going to be 4 minus negative 2, which is going to give me 4 plus 2. 4 minus negative 2 was my numerator. My denominator is going to be the difference in x's, 4 minus 1. That's going to give me 6 over 3, and that'll reduce to 2. So the slope of the first line is negative 1/2. The slope of the second line is 2. So that must mean that these lines are what? Related to each other. They've got to be perpendicular. Since the slopes are opposite reciprocals, well, actually, let's do this. Since the slope's product is negative 1, our lines are perpendicular. Go ahead. You can. Let's add this in there just as another layer to what we understand about perpendicular lines. Better?